Hey guys, so I just want to do a couple quick review things before you get into the math, just in case you need it. So the first thing is reviewing the two types of waves that we have. So we have transverse waves that look kind of like the snake, and they have two main parts. Those two main parts are the very top, which is what we're going to call a crest, and the very bottom, which is what we call a trough. In order to make one wave, you need one crest and one trough. So here I have two crest, two trough. I have two waves. So right there would be the end of one wave and the beginning of the next. The other parts that we have are amplitude. And for amplitude, we're going to imagine this kind of line in the middle, kind of like almost like an equilibrium point. And to measure the amplitude, we start at that midpoint or at the equilibrium, and we measure up to the crest, and that would give us an amplitude. Since we're measuring up, that'd be like a positive amplitude. The reality is you could measure down. You could start at the equilibrium line and go down to the trough, and it'd be the same value. It would just give us a negative amplitude. So those of you that are in college algebra or pre-cal, you did trig, and at one point they taught you to look at the maximum and the minimum and divide it by 2 in order to get the amplitude. And the last big measurement that we look at is a wavelength. So wavelength measures one wave. So since we're starting at kind of that 0 point, then I want the distance till when I get to the next little 0 point after I've had a crest and a trough. And so that's the wavelength. That's that kind of funky upside down y. That's what we call lambda. Another way that I could do that math-wise is if I know the total distance that something goes, I could take that total distance and divide it by the number of waves, and that would give me my wavelength. Some other general terms that you were introduced to in the notes were things like period and frequency. So period measures the time that it takes for one wave or one circle to occur. And that's something we actually learned about in when we did our circles. So if in this case I have two waves, because there's two crests and two troughs, then I can take the total amount of time and divide by the number of waves, and that gives me the period. And the frequency is just the opposite of the period. So if I took the total number of waves and I divided by the total time, I would get the frequency. So we like to say that these two are inverses of each other. So if I want the frequency, then I could take the period and just put it underneath 1. Or if I wanted the period, I could take the frequency and divide it by 1. So they're really just opposites of one another. The other type of wave that y'all looked at was longitudinal waves, which have a couple of parts as well. Longitudinal waves have these kind of squished up sections. They usually are drawn kind of like slinkies, and that's what we call a compression. And then they have these kind of more spaced out sections, which is what we call a rarefaction. And so in order to make one wave for this, I'm going to need one compression and one rarefaction. So if I know this distance, then I would know the wavelength. Here I have two compressions and a rarefaction, maybe the beginning one, so I have like 2.5, maybe 2 3/4 of a wave. And we don't do as much with the longitudinal waves in terms of math, just in the sense that they're not quite as clean to look at. On this type of wave, the amplitude is going to be figured out by simply knowing how tight or how long this compression is. So the length of this compression is how we would measure the amplitude of a longitudinal wave.